Have you ever tried sending a large file to a friend or colleague, only to stare at the progress bar moving at a snail's pace? It's incredibly frustrating, right? You've got a super fast internet plan, so why does it feel like you're sending data through a straw? Today, we're going to unravel the mystery of slow file transfers. We'll dive deep into the hidden world of network transmission and discover what's really happening behind that loading screen. To understand this, let's start with a simple idea: transport. When you send a file, you're not just magically beaming it from your computer to another. You're actually transporting data. And just like any kind of transport in the real world, it involves a complex journey with many potential slowdowns. Think about it, sending a package across the country isn't instant. It has to travel on roads, get sorted at hubs, and deal with traffic. Your data does something very similar, but on the digital highways of the internet. So let's use a metaphor to make this super clear. Imagine the internet is a massive, sprawling road network, connecting every city, town, and house in the world. Your file is like a huge shipment of cargo that needs to be delivered from your home to your friend's home. Now, this cargo is too big to fit on one truck. So you have to break it down into thousands of smaller boxes. In the digital world, these little boxes are called data packets. Your computer breaks your big file into these tiny packets before sending them out. Let's introduce our first key concept: bandwidth. Bandwidth is like the number of lanes on a highway. If you have a highway with 10 lanes, you can move a lot more cars at once than on a single-lane country road. A high-bandwidth internet connection means you have a wide, multi-lane highway for your data packets. A low-bandwidth connection is like that narrow country road. So more bandwidth means more packets can be sent at the same time, which should make your file transfer faster. But as we'll see, it's not the only thing that matters. Now let's talk about traffic. Even on a 10-lane superhighway, if it's rush hour and everyone is on the road, things are going to slow down to a crawl. This is called network congestion. When you and your neighbors are all streaming 4K movies, gaming online, and video calling your families at the same time, you're creating a digital traffic jam. All your data packets are competing for space on the same road out of your neighborhood, which is the shared line to your internet service provider. This congestion significantly reduces your effective speed, no matter how wide your highway is supposed to be. But the journey doesn't end at your local neighborhood. Your data packets have a long way to go. This brings us to another crucial concept: latency. Think of latency as the time it takes for a single truck to travel from your house to its destination, even if the road is completely empty. This travel time is affected by two main things: distance and traffic lights. The physical distance between you and the server or person you're sending the file to matters. Sending a file to your neighbor is quicker than sending it to someone on another continent because the physical distance the signal has to travel is shorter. And what about those traffic lights? In our network analogy, these are the routers, switches, and servers that your data packets have to pass through. Each one of these devices is like an intersection or a sorting hub. When a packet arrives, the router has to look at its destination address and figure out the best road to send it on next. This takes a tiny amount of time, but when your file is made of millions of packets, and each one has to pass through dozens of these intersections, those tiny delays add up. This is latency, or what gamers often call ping. High latency means each packet takes longer to complete its journey, which slows down the whole transfer. So you have your fleet of trucks, your data packets, driving on the highway. But what if the road is bumpy? This leads us to our next problem: packet loss. Packet loss is exactly what it sounds like. It's when some of your data packets get lost along the way. In our metaphor, this is like a truck hitting a giant pothole and some of its cargo falling out and getting left behind on the road. This can happen for many reasons: a faulty cable, an overloaded router that just drops packets it can't handle, or wireless interference if you're on Wi-Fi. When a packet is lost, it creates a big problem. The receiving computer is sitting there, assembling all the packets back into the original file. Suddenly it notices, hey, I've got packet number 99 and packet number 101, but where is packet number 100? It can't just ignore it. It has to send a message all the way back to the sending computer saying, I'm missing packet 100. Please send it again. The sending computer then has to stop what it's doing, find that specific packet, and resend it. This back and forth process of detecting a lost packet and retransmitting it adds significant delays. Imagine having to stop your entire delivery convoy just to send one truck back for a single lost box. A high rate of packet loss can absolutely cripple your transfer speed. Now let's put it all together. The core insight here is that the internet is fundamentally an unreliable transport channel. It was designed for resilience, not for guaranteed speed. When you send a file, you're sending thousands of little packets on a chaotic journey. Each packet might take a different route. Some might get stuck in traffic, some might have to wait at intersections, and some might get lost entirely. The final speed you experience is a combination of all these factors. Your bandwidth determines the maximum number of packets you can send at once. Your latency determines the base travel time for each packet. Congestion on the network path adds traffic delays, and packet loss forces constant stops and retransmissions. It's a delicate dance. Think about your own computer and the destination computer too. They are the starting and ending points of this journey. Their own processing power matters. If your computer is old or busy running other programs, it might be slow at breaking the file into packets in the first place. Similarly, if the receiving computer is slow, it will take longer to acknowledge the packets it has received and reassemble them. They are the loading docks of our logistics operation, and if they are understaffed or inefficient, the whole process gets bottlenecked right at the start or finish. So the next time you see that progress bar crawling, you'll know what's happening. It's not just one thing. It's a complex interplay of your available highway lanes, traffic from everyone else on the internet, the distance and number of stops along the route, the quality of the road surface, and the efficiency of the loading docks at each end. Your advertised internet speed is just the speed limit on your local stretch of highway, but it doesn't account for the traffic, the construction, and the long journey ahead. Now, all this complexity leads to an interesting question. With all these packets getting lost or arriving out of order, what happens if your internet connection drops completely in the middle of a huge multi-hour transfer? Do you have to start all over again from zero? Can you somehow pick up where you left off? Well, the ability to resume a broken transfer is one of the most important features of modern file transport, and the way it works is a fascinating story in itself. We'll be exploring exactly how that magic happens in our next video. Thanks for watching! If you found this explanation helpful, give us a like and hit that subscribe button so you don't miss our deep dive into resumable transfers. See you next time.